I don't know how well this is going to play, but let's see. I knew I shouldn't have put an animation on the front. Okay. So I'm going to talk about the autumn night sky and some of the things that you can see in it. Oh, look at that. That's a little bit nice. This is PowerPoint, Office 365 for the geeks. It's I did very little for this. PowerPoint did everything. Right. So what I'm going to talk about are things like Mars, which is at opposition. So a few minutes before I logged on, I took a picture of Mars, not through the telescope, but just with the camera, because it's so bright. I don't know if you've got a window view from where you are, but if you look towards the east, Mars is just above the horizon now. And it is so bright. I mean, it's much brighter than Jupiter at the moment. I want to tell you about some of the meteor showers that you can see over the autumn. There is one comet. It's not brilliant, so don't build it up. There's a conjunction of Jupiter and Saturn, which is coming in December. I want to show you some deep sky targets for binoculars and telescopes. Okay, I'll do that on Stellarium, and we can just scroll around the sky and have a look. I'll do the same for the astrophotography targets, but really my emphasis this week is not really on astrophotography. And intriguingly, that last entry there, I want to set a challenge for people. This will require a camera. Sometime over the autumn, we're going to try and capture Mercury's tail. The planet Mercury, it has a tail, okay? So we're going to try and find it on some pictures at some point, okay? Right, this was a picture of Mars taken a couple of days ago because, the sky's not often clear in Northumberland, and I thought that's the best it's been for a while. So I thought I would just emphasize how brilliant Mars is at the moment. So that's it kind of shining high above the southeastern horizon at about 10 o'clock. There's a lot of moonlight in the sky, but Mars just dominates. It's so bright, you can't miss it. Opposition, that means it's kind of like in a straight line with the sun, the earth in the middle, and Mars on the outside. Because of the varying speeds of Earth and Mars going around the sun, just like hands on a clock, the two line up every so often. And for Mars and the Earth, it is roughly just over every 2 years. Okay, it varies a little bit because of Mars's elliptical orbit, which means it travels around some of its orbit a bit faster at some times than other times. It has a very oval-shaped orbit. This has a big effect on how we view the planet from Earth, because it means that sometimes when the two planets line up, the space between them is a mere 35 million miles. But if they line up on the wrong side of their orbits, Mars is still at its closest to Earth, but the distance can be nearly double that. So it has a dramatic effect on how Mars appears through the telescope in terms of its size. These really good oppositions of Mars occur every 15 to 17 years. And the last so-called perihelic opposition was 2018. But from our point of view in the UK, this wasn't great because Mars was in the constellation Sagittarius. And if you want to visualize where that is, picture where the sun is in the sky at midday on the solstice in December. It wasn't very high above the horizon. It gave poor views most of the time through a telescope. So even though it was closer then, we're getting a better view of it this year, just a slightly, couple of million miles further away, but it's much higher in the sky. We're viewing it through much less of the turbulent layers of Earth's atmosphere, and therefore we get a steady view of it through our telescopes or with our cameras much more often than we did a couple of years ago. Here's a picture of Earth's orbit in blue and Mars's orbit on the outside in red, and it shows these oppositions, these times where Earth and Mars line up, and you get your minimum distance. And you can see that because of Mars's more eccentric orbit, the distance changes quite dramatically. So here we are in 2020, and you can see that the next opposition in 2022 will be a little bit further away. And then the one after that in 2025 will be much further away. And it just gets worse and worse until you get into the 2030s, when Mars begins to approach the Earth again. And then the opposition of 2033 will be nearly as good as this one, but the opposition in 2035 will be a little bit closer. Okay, so I haven't seen that many perihelic oppositions of Mars in my life. The first one I remember was 1988. Then it was 2003, and now it's kind of like 2020. So it's you know, you don't get many in your life. You've got to take advantage of these things, which influenced my spending rather a lot earlier in the year. But never mind. Oh, this has been recorded. Yeah, I must not watch this. Okay. So like through a telescope at opposition. And you can see in 2018, it had a massive size of 24.2 arc seconds. Just as an idea of scale, I worked this out, and 22.4 arc seconds, which is what this year's opposition is the equivalent of observing a £1 coin from a distance of about 220 meters. Okay, so that should give you kind of like some visualization of how small Mars is, what a small target it presents for telescopes, and that's as good as it gets. At all other times, it's usually much smaller than that, except at oppositions. Well, you know, I've been out every opportunity to take pictures, and this is my little library of Mars images that I've taken with my 8-inch telescope, and not a really expensive camera either. It's a cheap kind of black and white mono camera. The key to getting pictures of Mars is to wait until it's higher in the sky, so kind of later in the night. At the moment, that's after midnight. And what you have to do is to take as many pictures as possible in as a short period of time as you can get away with, because Mars spins on its axis every 24.5 hours. Through my telescope, if I spend more than 2 minutes taking pictures of Mars, it motion blurs and you can't stack the images. So I've got a time limit of about 2 minutes, and I have to get as many pictures as I can. And for me and my telescope and my camera, that works out at about 4,000 pictures. And I stack the best, maybe 30 to 50% of them. I sharpen them up, and I end up with a picture like one of these if I'm lucky. When you're observing Mars, because it has a day about half an hour, 40 minutes longer than our day, if you go out at the same time at night, Mars will present a very slightly different face towards you. It'll be shifted by about 40 minutes of rotation if you look at the same time on each night. So when you look at these pictures of Mars here, you can see some of the features are shifting across the planet because I'm out roughly at the same time in the evening, but Mars has rotated a little bit less in that 24 hours than a complete revolution. So if you look at the central picture here and the picture over here, they were taken a few days apart when Mars had shifted its position a little bit on its axis. Over the next week or so, what I'm really looking forward to, if the weather can hold up, is getting a picture of the Valles Marineris, the Mariner's Canyon, the big thing that's hundreds of times bigger than the Grand Canyon on the Earth. I think I've just about got the resolution to get it. Doing astrophotography of Mars or long-time visual observing, you really get to know the planet a lot and the features on it. Jen's asking what scope I've got, and it is a Meade LX10. So it's quite, I think it's probably an obsolete telescope, but it's a Meade telescope. It's a Schmidt-Cassegrain, and it's an 8-inch aperture. So it's a moderate sized telescope. It's not a really big one, but it's not a small one either. There's a feature on Mars which I was never able to see until I managed to take a picture of it, and it just suddenly popped out. There's a feature called Solus Lacus, and its nickname is the Eye of Mars. And I never really saw it until I took a picture of it. But if you look at this picture down here, I don't know if I can draw on here. I might be able to, but just to highlight it. Can you see in the center of that picture in the bottom left, an eye looking back at you? It's around there. Look at that. It's like an eye, the Eye of Mars. And that was noticed by observers way back in the 18th century as well. So it was nice to be able to see that, and I've since seen it visually as well. I've seen it just by looking through the telescope. So yeah, Mars is just past its closest to Earth, but it isn't quite yet in opposition. So there's, I think it's just the 16th, something like that, that it's actually directly opposite the Sun. But it's on its way out now, okay? So it's getting further away from us. But over the next sort of 6 weeks, it'll still be relatively easy to observe the planet through a telescope and to get good pictures if that's your thing as well. Okay. Mars has 2 moons. They're named Phobos and Deimos. This is Asaph Hall, an American astronomer who discovered them visually. He was using the biggest refractor in the world at the time, a 26-inch refractor at the United States Naval Observatory. And he had worse weather than we do in Northumberland. Where that observatory is, it's plagued by mists and fog from a local river. And his diary of his attempts to discover moons around Mars reads like a Northumberland diary of astronomy would as well. It's like he thinks he sees something one night, but then the mists come in at midnight and he loses it. And he's trying for a few weeks, and eventually he discovers Deimos, the outermost moon. And then he discovers Phobos, and then he reports his discoveries after that. Mars is the god of war in Roman mythology. Phobos and Deimos, I think, mean fear and panic. So they're the attendants of war. I'm highlighting this because I managed to take a picture of the 2 moons a couple of nights ago. I've been trying to do this for years, but Mars, when it's not close to the Earth, the moons are so close to Mars that it's very, very difficult to see them over the glare of Mars. I mean, I've got complete respect for Asaph Hall because he just observed them. I know he had a big telescope, but to see these things is incredibly difficult. I think the smallest telescope I've read about anybody visually observing is something like a 10-inch telescope. When you see a picture, this is a picture I took a couple of nights ago. I've overexposed Mars in this picture, and the 2 dots to the right of it are the 2 moons. And they're at their furthest distance from Mars in that picture. So Phobos is the innermost, Deimos is the outer one. If Mars wasn't there, there wouldn't be particularly difficult things to see, but Mars is more than 1 million times brighter than the 2 moons. Deimos is actually the easier one to see, although physically it's the smaller of the 2 moons, and Phobos is a bit closer in. How did I know? How do I know they're not just background stars? Well, stellarium's pretty good. So what I did was I made sure I was observing on a night where the 2 moons were at their furthest extreme from Mars at a greatest elongation. So just to show you that stellarium rendition for that picture, so just wind it back. You can see the field stars in the background there, but Phobos and Deimos and their orbits, and you can see Mars, which is in the middle of that overexposed mess in the middle, is that's definitely the 2 moons. So my camera settings, I picked it up on an 8-second exposure at ISO 800 on the Nikon D90. So you can pick it up, but the trick is to kind of like, if you underexpose, you're not going to get the moons. But if you overexpose, you'll have more light from the moons, but you'll also have Mars, which seems to expand outwards with the length of the exposure. So it takes a bit of trial and error to get it right. So I think I ended up taking around about 20 pictures, and I could see the 2 moons in 3 of them. So I stacked them, and it gave me like 60 seconds time, something like that in total. So after about another 6 weeks, it's going to be very difficult to see those either visually or with a small telescope like mine. Just before the meeting started, I took a picture. So that was taken at 7:20, and it was looking out from one of the bedroom windows upstairs here towards the east. and Mars was above the horizon, and it's just brilliant. I can see it now looking out the window, out the patio doors. It's just there in the eastern sky. So I'll be out after this. I'm going out to try and get some more Mars pictures. It's the brightest thing in the sky after Venus at the moment. It's even brighter than Jupiter in the southern sky. So as time goes on, as we go into the next few weeks, Mars will rise before sunset, and it'll be higher in the sky as dark falls. So, you know, this is the ideal opportunity to get out and have a look at it. Speaking of Venus, Venus is in the morning sky. If you're up fairly early and you look out before sunrise, you can see it hanging over the eastern horizon. It's actually past its best in the east before sunrise. It reached its highest altitude at about the middle of September. So over the next few weeks, it's going to sink down towards the southeastern horizon, and you'll see it for a shorter and shorter window before sunrise. So it's not really going to fade very much, but it's going to drop very low towards the southern horizon. And in fact, after January, early January next year, it'll pass behind the far side of the sun and reappear in the evening sky, but it'll be positioned for most of next year in the evening sky, almost on the horizon at sunset. So this is our last really good opportunity to see it until the back end of 2021. Okay, it's still possible to track the planet down during daylight. It's actually, if you can find it in the daylight sky, and it's easily visible with binoculars, you can actually see it with your eyes if you're looking directly at it in broad daylight. You can still observe Venus through the day, and it's actually preferable because sometimes it's higher in the sky and therefore you get less turbulence in the atmosphere and all the rest of it. So it's an interesting thing to try and do, track Venus down during the daytime. This was another picture taken just before this meeting. In the southern sky, I'm sure you can't fail to have noticed that Jupiter is there. And in fact, Jupiter and Saturn are visible next to each other. So Jupiter's brighter. It's the one on the right here. Saturn is marginally higher on the left, but not quite as bright. They've just been like that. They've seemed to have held that pattern in the southern sky for the last few months. But what you'll notice now, moving forward towards the end of this month in November and December, is that Jupiter is going to close the gap on Saturn. And in the third week of December, the two are going to be very difficult to separate by eye. They'll be so close together in the sky. This event is called a conjunction, and they're very rare for Jupiter and Saturn. So the evening of December the 21st, Jupiter and Saturn will be shining almost as a single star. Okay, if you've got good eyesight, you should still be able to separate them, and it'll be easy in binoculars. So that's kind of a rendition from Stellarium of the evening sky on December the 21st. You'll see that Jupiter and Saturn are very low in the southwest at this point. So you don't have much of an opportunity to see them shining together. So you need to get away so that you've got a clear view of that part of the sky. And you've obviously got to hope it's clear as well. And if you've got a telescope, you do have a larger window of opportunity to observe them because both planets are visible with telescopes in daylight. So you could get your telescope set up in the afternoon and just follow them with your telescope and get a good view of them as they approach each other through the eyepiece. They're actually going to be so close to each other that they appear together like this through a telescope. So that is spectacularly close. Conjunctions of Jupiter and Saturn occur every 20 years or so, okay? Jupiter goes around the sun every 12 years. Saturn takes nearly 30. So every 20 years, Jupiter catches up on Saturn and they're fairly close together in the sky. But conjunctions this close are even rarer, okay? We're not going to see another one in our lifetimes like this. So what a picture. Again, what a picture. Or just to be able to see that. So the moons of Jupiter, the 4 brightest moons, and maybe 2 of Saturn's moons, if it's in twilight, we should be able to see Titan and Rhea without a problem. So that's a very special event, and no doubt we'll mention it again at some point at Nastro before December. There are some showers over the coming weeks. I just want to see if I mention another one. I'm going to mention this one first. I think it might already have happened. The Draconids. This one made it onto the radio and TV yesterday. I was really surprised because this is one of the weakest showers. It only has the occasional outburst. Historically, so 1933 and again in the 40s, there was a storm of meteors from this. So rates of tens of thousands per hour for a very brief period. Typically, you see less than 10, okay, per hour. And that assumes you can see the entire sky in one view, that your sky is completely dark, no light pollution, no clouds, clear view to the horizon and all the rest of it. Perfect conditions, you might see 10, okay? So normally, this is probably not one I would really pay attention to because there are better, more consistent meteor showers than this. But if you happen to be out like tonight and it's clear, then any meteors you see could well be from the Draconid shower. It's named the Draconid because the meteors radiate away from a point in the constellation Draco, the dragon, okay? In that little star chart that you can see there, the radiant of the shower is near the head of the dragon. The head of the dragon is near a bright star called Vega, okay? Now, the radiant of the shower is above the horizon permanently. It's always above the UK horizon. So if you're looking for meteors, they will stream away from this point in the sky. So you might see one across here. You might see one shooting through the plough like that. You might see one over here or over here. If you see one doing that, that's not a Draconid. Okay, so you will see other meteors because there's a background count of meteors all the time. But if you can trace the path back to that part of the sky, it's very likely a Draconid. So that the peak of that is the 8th, which is tonight. Okay, but I think, well, they were talking about the peak yesterday, but that's the one that's given on the International Meteor Organization website. So I would trust that one. The peak could be tonight. The next shower is the Orionids. And again, this is best seen in the morning sky because Orion doesn't rise until kind of like late evening, and it's not high in the sky until the hours after midnight. So there are a few other meteor showers active. I'll just talk about them because they're on the screen here. There's a comet called Encke's comet. It's the comet with the shortest period. It whizzes around the sun every 3.3 years. And because it's going around so quickly and its orbit is perturbed by the planet Jupiter quite regularly, the material from the comet has spread out over a huge swathe of the inner solar system, and the Earth passes through this material during November. And because it's gone around the sun so many times and the particles have been allowed to spread out over this solar system, there are multiple peaks. So you don't have like a single torrid meteor shower. What you have are multiple meteor showers from the constellation. Well, they're not in the constellation Taurus, but because the radiants have drifted. This is Taurus over here, and the radiant is now in Cetus and Aries, but they're still referred to as the Taurids. But anyway, they're there, okay? So the meteor shower radiants drift as well each day because of the motion of the Earth around the sun, because the direction a meteor appears to come in the sky depends on how we're moving and how the particles are moving. So if we change our direction as we go around the sun, the meteor shower will appear to come from a slightly different direction, so it'll drift. So I guess what will happen is, as you get into November, these radiants will drift that way slowly. So the Orionids is a better bet. So the peak is the 21st and 22nd, but you need to be up fairly early looking at it. So something like 3 to 4 o'clock in the morning would be a good time when Orion's nice and high in the sky. In November, we have the Leonid meteor shower. Again, this is one for the early morning sky. The radiant is in the constellation Leo. This is another famous one because it is associated with the occasional meteor storm. So beginning in the 18th century, every 33 years, this thing would erupt in a storm where hundreds of thousands of meteors would rain down in a very short period of time. And then you'd get quiet years. It was this shower which allowed astronomers to connect meteors to comets, because there's a comet with a 33-year period. And if you triangulate the position of meteors as they come into the atmosphere, you can figure out where they came from in the solar system. And the path followed by these meteors was linked to the same path followed by a comet, which was known at the time. So this one has occasional storms because we think it's a relatively new meteor shower, and the material is clumped not far behind the comet or not far in front of the comet. So there were occasional bursts and storms when the comet was nearby the Earth at the same time. Over time, the material will spread out around the entire orbit of the comet and become much more uniformly distributed. These storms, unfortunately, Jupiter has stopped them. Okay, the party pooper Jupiter. Jupiter's gravity shifted the orbit of the comet in the late 90s, so that the last storm was 1998, and there likely will not be one in the 2030s. So, you know, I'm not going to pin my hopes on seeing that one. So unfortunately, we now have just the usual, not quite background count, but maybe 50 meters per hour from this one. Not a dramatic ball. Finally, when you do get to December, one of the consistent meteor showers of the year. Okay, so this is reaching a peak around about December the 13th. The rates can be incredibly nice, like 150 per hour. So if you're going out to have a look, you don't have to wait more than a couple of minutes to see one. The constellation Gemini is in the eastern sky in the early evening. So it's above the horizon. You don't have to wait until after midnight, or you will get better rates after midnight. And it's kind of a really nice one to watch. It's consistent in the high numbers every year, and it's easy to find. And Orion's above the horizon, and it's nearly Christmas, so you're in the mood for a good meteor shower anyway. So that's the Geminids. There's another one I'm not going to mention. It's the Quadrantids, and I'll probably talk about that another time, but that's early January, and it's just after New Year, and everyone's depressed, so, and it's in the middle of the night, so you're not going to see that one. Okay, comets. Comet Neowise is coming, but not the one we saw. Okay, not that one. That one's gone. There's another comet Neowise. It's a tiny little comet, so we're not expecting it to put on a spectacular. It was discovered in August. It goes by the official moniker 2020 P1. Okay, so not 2020 F2, which I think was the really big bright Neowise. It reaches its minimum distance from the sun on October the 20th. After that, it'll be visible briefly in the morning sky over the southeast horizon, if you know where to look. It's not going to be a naked eye comet, we think, unless it does something extremely dramatic. But it should be visible with small telescopes, maybe binoculars if we get really lucky. Okay, it's going to be in the constellation Gemini. The star map, I just kind of printed it about an hour ago with the latest orbital. And you can see, maybe if you recognize your constellations, you can see there's a star over on the left of that picture called Arcturus, which is basically the brightest star in the northern sky. So if you're out at like 6 o'clock in the morning, looking towards the east, the comet will be roughly level with Arcturus, but more towards the south. Okay, but you'll need to get the position and put it into your telescope and look for it. So it might be a nice comet because it's approaching the sun so closely, but we're not having big hopes pinned on this. But there's nothing else at the minute. Nothing else. Okay, the last thing before we do a little bit of kind of like things to look for on the night sky is Mercury's tail. I should say hands up if you didn't know Mercury had a tail. I kind of knew about Mercury's atmosphere, but I wasn't aware that the tail was something you could see from Earth until fairly recently. So just a bit of background. Mercury is the smallest planet in the solar system. It's a small rocky planet. It has a very heavily cratered surface. The picture there is from the Messenger spacecraft. It's an image taken probably nearly 12 years ago now. And because it's such a small planet, it doesn't have the gravitational pull to hold onto an atmosphere. However, because it's so close to the sun, it basically feels the full brunt of the solar wind, all of those energetic particles being blasted away from the surface of the sun. They strike Mercury at an incredible rate and speed. And what that does to the surface is it blasts particles, hold onto these fast-moving particles very well. So they spend a little bit of time in the neighborhood of Mercury, but then their incredible speed just takes them off into space. Now, the surface of Mercury is quite complex, but the elements that are there are things like hydrogen, helium, oxygen, sodium, potassium. There's even water on Mercury. At the poles of the planets, there are craters where it is permanently dark. Sunlight just doesn't reach to the floors of some of these craters. So Mercury does have water, and it mostly remains locked up in the soil of Mercury. But as a result of all of this kind of like activity from its, not quite an atmosphere, its exosphere, some of that water vapor can get released as well. So what causes the tail is this stuff being pushed away in the same way that sunlight acting on the material of a comet does. When comets approach the sun, the material that sublimates and is ejected from the surface of a comet streams behind it. The solar wind, those energetic particles, push the particles from the tail of a comet away from the sun. And likewise, with Mercury's extremely here, these particles are also pushed away from the sun. How you can observe them is the fact that I think some of them are what are known as excited, which is a chemistry term for kind of the electrons are pushed into a higher energy level, and then after a while they fall back to that low energy state and release a particle of light. So for Mercury, the brightest part that we can see is caused by sodium atoms. So the presence of sodium in the exosphere, which is then pushed away by the solar wind, is a bit that we could potentially see from Earth. It was only discovered less than 20 years ago, so we didn't know about this for sure. And actually, amateur astronomers now treat this as a bit of a sport to see if they can photograph the tail of Mercury. So you might have seen this picture already. It was astronomy picture of the day a little bit earlier in the year. That's not a picture of a comet. That's a picture of Mercury taken with a small telescope, but with filters. The kind of filters you need is something which will let through the light of sodium, which is a kind of orangey light. If you think of sodium street lights, that's the kind of filter I guess you would need to let through the light. It would also have the effect of blocking out things like blue light, which would be important because we usually observe Mercury not in a completely dark sky, but a slightly twilight sky with blue in it. So if you can block some of the blue, you can increase the contrast. So I think the story behind this picture is that it's just a normal picture of a starry sky and some images which are stacked. So they're not really long exposures. They're probably, 30 seconds, because if you do too much longer than that, the sky gets too bright. So it's a series of stacked images. But even in the images, if you look carefully here, you can see there's star trails. Okay, so this is stacking not on the stars. It's stacking it on to keep the position of Mercury fixed, because Mercury is actually moving so fast around the sun that even if you're observing it for like half an hour, it moves appreciably in those few minutes. So you've got to stack on Mercury so that you don't smear out the tail. Geometrically, the best time to try and look for the tail is when you've got your best view of it, when it's pointed kind of like away from the sun and you're looking at the length of the tail. And that corresponds to a time when it's near what we call a greatest elongation, which happens to be the best time to see Mercury anywhere. The situation is complicated by the fact that we're in the UK. Okay, we're in the Northern Hemisphere. We get the worst deal when it comes to looking for Mercury because it's got a weird shaped orbit like Mars. It happens to be, when it's well seen from the UK, it's not as far as it could be from the sun. Okay, so we never get the best view of it. So we don't have that many opportunities to do it. So what we need is a good elongation where it's far from the sun, and also when it's high above the horizon at the same time. And that occurs this year in November. So the goal is go out and see if you can take a picture of Mercury's tail. There really are not a lot of pictures of it, other than in specialized astronomy forums. Okay, so I'm going to give it a shot. The advantage of this is if you're looking before sunrise in Northumberland, that means you're looking out over where there's no near the sea. So I'm going to give it a shot in November. Right, okay. I'm going to stop briefly while I change screens, but does anybody want to ask anything about that before we kind of boot up Stellarium? Oh, where's Stellarium? Got to open Stellarium. That'll be a start. Here we go. Well, like I say, if you've got any questions, you can type them into the chat. Let me just open Stellarium. Just wait for it. Nearly there.
While it's loading up, Adrian.
Yep.
Can I just ask a quick one about stacking lunar photos?
Yes.
The moon the other night, and I had to go in Astro Stack Art and didn't have any success. So,
right.
Which would you recommend?
What kind of pictures? Were you taking pictures through a telescope, or was it like the whole moon that you could see?
It was the whole moon through a telescope.
Okay, so you could see all of it.
Yes.
Let me just switch over to that just briefly. When you're stacking in Auto Stack Art, you don't really need to change that many of the settings. For stacking a picture of the entire moon, what you're aiming to do is to set it to planet if it's the whole moon, because basically Auto Stacker doesn't know whether you're looking at Mars or Jupiter or the moon. It's just a shape, which is the entire object. So you've got to set it to planet if you're looking at the whole moon. I would just leave the default settings. There's one to do with noise, and you could just leave that and see how it does. What you do need to set, after you've done that, you just kind of like get it to analyze the image. And then what it does is it goes through all of your images that you've got. So how many pictures did you have to stack?
I think it's about 50.
So that's not a huge amount. Did they load into Auto Stack it okay? Were you able to kind of like move the slider and see that the images were there?
Yeah.
Okay, so you just use the default settings, use it for planet. And then when it comes to your align points, because you have to kind of like set them in that second window, did you click on like, there's a one for doing it automatically?
I did.
Now the size of your align point can vary. You probably don't want them to be really small and hundreds and thousands of them. You just want them to be like medium sized probably, and to have maybe 50 or 60 and see how you go with that.
Yep. Okay.
And when you do that, you then, yes, I'm sorry, I'll just finish talking about this briefly because it's just in my mind. When you do that, you then have to tell it how many % of the images you want to stack. And it depends on like how good your pictures are. If they're quite sharp and they're good, you can use maybe most of them. So like use like 50%, 70%. If you think some of them are a bit rubbish or a bit blurry, then use a smaller number. So you might want to stack 25 of that 50. You might think I can only stack 10 of them. But this is just like the first kind of like step. After you've stacked the images, you would then need to go on and maybe, if you thought they could be a bit sharper, use something like Reggie stacks. But anyway, we can talk about that. I was thinking about putting a little video together about how to do like planetary images and moon images, because I use the same thing now all the time and it seems to work. So I might do a little like how-to video the next time. Well, hopefully I'll get some pictures of Mars tonight and I might do it with that.
Perfect. Thanks.
Okay. Right. Where is Stellarium? Oh, why is it not showing up? Oh, do you know, I bet that's because I didn't open it before I did this. Right, I'm going to try and do something which might be disastrous. I'm going to log out. Kathy, you're the host. I'm going to log out and come back in okay, because it's not picking Stellarium up, and I think it's because I didn't open it before I did this. Oh, hang on, wait, no, still not there. Oh, there it is. Ooh, that was lucky. Got it. Sorry, there it is. Phew. Just edit this out. It in. Right. It might be difficult to see because it's quite dark on here. I wonder if I can lighten things a little bit. It looks like quite a dark screen. This is real time. Okay, so looking at the southern sky. Are you able to see the Milky Way on this and some stars? And can you see things happening on here?
Yeah, I can see the stars.
All right. Okay.
And Milky Way as well.
Right. Cool. All right. That's good. So this is a view of the southern sky. Now I'll start with this, just this view. Maybe zoom out a little bit. This is the best time of the year to see the Milky Way. So therefore, most of what I'm going to tell you involves the Milky Way. If you've got binoculars, just scan along the length of the Milky Way. The moon's gradually moving out of the evening sky at the moment. So on those clear nights that we do have, like now, the sky is incredibly dark and the Milky Way should be easier to see. The bits that you can see particularly well from the UK, it's the bits around the summer triangle. So I'm going to try and switch some stuff on here. Constellations, maybe. Yeah, there we go. I can even annotate. Oh, this is so cool. Right. Okay. So look, let's see if this works. It's probably going to be black, the color, isn't it? Right. Color. Let's do yellow. Okay. So the summer triangle, better do a straight line, is from here to Vega, Vega down to Altair, and from Altair back up to Deneb. Okay, so that brilliant pattern of stars in the sky is the summer triangle, formed from the three brightest stars in three different constellations, which if I try to switch on, I'm just going to get rid of that. Switch the constellations on, you can then see them, okay? So the constellation names there. This section of the sky with Cygnus, and to the south of that, Sagitta, and then to Altair. If you just sweep through that area with binoculars, you'll just be blown away with the number of stars that you can see. So any pair of binoculars at all, you know. Sometimes I think that the wider the field of view, the better. You'll just be lost in these star fields in that part of the sky. Stellarium is showing things that you won't see with binoculars. It's showing these very rich pink clouds of hydrogen. So we have something called the North America Nebula there. These are good astrophotography targets at this time of the year. So you've got Deneb, which is the brightest star in Cygnus. It's a blue supergiant. We don't know how far away that star is. It's something like 2,000 light years, but there's a lot of uncertainty there. It's an absolute celestial powerhouse of a star. And it's probably the star responsible for heating up hydrogen in this nebula. Hopefully you can see at this point why it's nicknamed the North America Nebula as well, for that shape. So that's a popular target for astrophotographers, but you need a wide field of view to really pick up the entirety of it. I know if you've got a telescope, some people concentrate on just this bit of it. It's called the Cygnus Wall. Okay, so this is a really nice region in it for astrophotographers. Visually, it is possible to see it, and it's probably more easily visible with binoculars than with a telescope. Okay, with a telescope, I've seen it with a filter in place. You can get like ultra high contrast filters for your eyepiece, or you can get like what's called an oxygen 3 filter, and it basically blocks out everything except this light from either hydrogen or oxygen. So those filters will help you see it visually, but it's not difficult to pick it up with a camera as well. You can see around the second brightest star, Cedar. There's another region around here as well. And the whole, this part of the Milky Way is just filled with hot hydrogen gas, and it shows up in pictures. If you move through the constellation, if you've got a small telescope, you should definitely just take the time to point it at that star at the bottom. I say at the bottom, it marks the head of the swan. If I switch the picture on, we'll be able to see that, won't we? There. Of course it's a swan. What else could it be? Next to the fox, which looks like a stick. So if you take a look at that star, Albirio, it's not going to do it justice on here, but it separates into components. This is a double star. For a long time, we didn't know whether Albirio and its companion were a genuine binary system, meaning that the stars orbit around each other, or whether it was just one star a very long way away behind another star. It turns out to be the latter. The Gaia spacecraft has measured the distances of these stars, and the fainter star, I think, is a more distant star than the primary in this case. So it's just a chance alignment. The reason you should take a look at it through the telescope is that the colors are just spectacular. It's a lovely golden, yellow, bright primary. And the contrast with the fainter one, it looks bluish or even greenish in comparison. It's one of the showpiece double stars of the night sky. Any telescope will show you those two components. So that's Albirio, marking the head of the swan. Now, in this part of the sky, there's a planetary nebula as well. Now, how I usually find it is like this. Once you've found Albirio, there's a little pattern beneath it called Sagitta, which is an arrow. So if I take the lines away, I don't know if you can still see the shape, but it looks like a line of stars with a tail here, okay? So Sagitta, the arrow. If you can see that shape, what I used to do is I used to like point the finder scope at that star, and then I would move up to about here. So somewhere around here, if I've got this right, I used to do this on observing evenings. It used to be a genius finding it. And other times I think, oh, the telescope's not quite lined up here. But if I zoom into here, please be one of those times I look good. There it is. Look, you see it's popping into view there. Anybody know what that is?
Dumbbell.
The dumbbell. It's a dying star. So that little star in the middle there is going to become a white dwarf star. It's the core of an old star, which is blown off its outer layers. So you've got this hot hydrogen, oxygen, nitrogen expanding away from the central regions, and it's leaving a star which will become a white dwarf. It's actually quite big. If you were to see the moon next to it, it's about half the size of the moon. So it's pretty big, and it is theoretically visible in binoculars, but any telescope will show you this little thing. Oh, look, a satellite. I take it that's real time as well, because this is updated with the elements. So the Dumbbell Nebula, Messier 27, is one of the brighter objects that you can track down with a small telescope. Just next to it in the sky is a pattern of stars which I absolutely love. It's called the coat hanger. Just going to zoom into it there. Hopefully you can see the shape of that as well. It's an upside down coat hanger. It's also known as Brockie's cluster. And it has a catalogue number of Colander 399. You've got to, with the telescope, with my telescope, I've got to look for it and slew the telescope to it. It's a really bright thing. But that catalogue number, that catalogue doesn't exist on my go-to telescope. So again, they're not perfect, are they? Go-to telescopes. But this is visible with binoculars. Your best view of it will be through a good pair of binoculars. And it's embedded in these rich star fields of the Milky Way. It's visible to the naked eye if you know where to look. It kind of looks like a little hazy patch. And if you've got really good eyesight, I imagine you could see the shape as well. So there it is in the middle of the Milky Way. Look, I'm zooming out and you can still see those stars just about there. So it's between kind of Albirio and Altair down here, but it's easy to find. Now, if we're in this part of the sky, here is Vega and the constellation is Lyra. So I'll switch the lines on for this. Lyra is a kind of rhombus shaped or a parallelogram almost, And if you look in between these two stars at the bottom, Sulafat and Cheliax, got Vega there, you've got that parallelogram there. Right in the middle of there, what am I going to find? Come on, tell me. You know what it is. What's in the middle of those two stars in that gap?
That'll be the Ring Nebula.
The Ring Nebula. Okay, let's take a look. Again, it's not the brightest thing you can find, but if you zoom in, look at that. There it is. The Ring Nebula. These things never look as colourful through the eyepiece of a telescope, but it is quite bright. And planetary nebula, like the Dumbbell Nebula I showed you before, they're called planetary nebula because William Herschel, the discoverer of Uranus, gave them that name. He thought when he looked at them that they were the pale disks of distant planets, but they didn't move. So, but the name stuck. And as you know, astronomers are very resistant to change, so they're called planetary nebula. The nearest connection to a planet would be that planets are made from the material ejected by this stuff, but it's a very kind of like thin link to that. Okay, so it's a dying star, and again, it's one of the more famous ones in the night sky, but it's easy to find because it's roughly halfway between those two stars in Lyra. Okay, I'm going to zoom out a little bit. Now, over in the western sky, you've got Vega, which is kind of nearly overhead, and Arcturus, which is sinking down towards the horizon. In between those two, if you imagine a straight line between them, you've got a constellation called Hercules. And again, if you can find this kind of like pattern of 4 stars here called the Keystone, if I switch off the lines, it's less obvious. It's not a really bright correlation. But if you're looking halfway between Vega and Arcturus, and I zoom into here, there it is, little fuzzy things starting to appear there. This is the Hercules globular cluster. It looks a bit weird in this picture because there are actually stars bright enough for Stellarium to try plotting them as part of its program. So it's putting them in front of the real picture where the stars don't look that big. So this is the brightest globular cluster you can see from the UK. Okay, so it's like 300,000 stars in there, and it's on display in the western sky in the constellation Hercules. There's actually another globular cluster in this region. I'm just going to, I think it's about there. Zoom in. There it is, not that far away. This is M92, which is the other one in Hercules. And again, if it wasn't for M13, people would be talking about this one, I think, because this is a really impressive globular cluster too. So Hercules has these 2 fantastic globular clusters. Now, globular clusters are not part of the disk of the Milky Way. If you look at it here, you can see the disk of the Milky Way, and we belong to the disk. We are inside the disk. The globular clusters form a halo around the disk, so you tend to see them looking away from the Milky Way. But another complicating factor, which I'm going to try and draw in this picture here, if you imagine, like, here we go. I'm not an artist, okay, but let's see. If this is the Milky Way, right, and you're looking down from above, you know, it's got like spiral arms that sort of do that. I'm not an artist, okay, but you know, a spiral galaxy has that kind of shape if you look down on it. And we in the Milky Way are kind of like out here somewhere. We're nowhere near the center. So if you look at a spiral galaxy from edgeways on, what you get is this view that you can see here with the Milky Way. So if you were kind of like looking along the Milky Way, you get the bulge bit in the middle like that. And then if you look in edgeways at the spiral arms, they kind of taper out a bit like that. Okay. Patrick Moore called these like 2 fried eggs clapped back to back. It's a nice description. Okay. So when you look at a galaxy, there are 2 kinds of open cluster, 2 types of star cluster. There are the globular clusters, and these are actually outside of the disk like this. They're dotted around. They orbit the center of mass of the Milky Way, but they're in random orbits traveling in different directions. So at any given time, They form a kind of spherical structure in the halo of the galaxy. Now, a funny thing is because we're kind of like out here, okay, we're near the edge. When you divide the sky into two, you find that there are very few globular clusters in one half of the sky, and most of them are in the other half of the sky, and many of them are in the same direction as the center of the galaxy. And this was like one of the first key pieces of evidence that we weren't in the center of the Milky Way, that we were offset from it. But anyway, all this goes to kind of like illustrate is that when you look at the night sky at this time of the year, this time of the year where you're looking at the part of the sky that has all the globular clusters, and many of them are in this direction towards the center of the galaxy, so towards the constellations Sagittarius and Ophiuchus in that part of the sky. So if I switch them on here, so there are lots and lots of objects to try and track down here. A real challenge at this time of the year is to try and track down the objects in the southern Milky Way. So I'm going to zoom into there and sort of show you the kinds of things that are visible. So as we zoom in, we're looking very low in the Northumberland sky. There we go. And this is one of the regions that I absolutely love trying to track down. We have this region here, which is the Eagle Nebula. Just below it, we have the Omega Nebula. And although these are pictures taken with probably filtered telescopes, if you've got a decent sized telescope, say like 6 inches or more, you can visually see these nebulas. They're as prominent, not quite as prominent as the Orion Nebula, but they're certainly visible through telescopes. So if we just quickly zoom in and have a look at the Eagle Nebula, this is the one which the Hubble Space Telescope captured as with the pillars of creation in the center of it. So that's a site of active star formation. Just below that, we have the Omega Nebula. Again, it's probably part of the same complex of gas and dust as the Eagle Nebula, but again, visible with binoculars. You get the idea that as I'm randomly slewing around the sky, imagine I'm taking pictures of this, how often satellite trails go through this, and it's only going to get worse because of Starlink. Urgh. Right, okay. A little bit further south of that, to the eye, this just appears like a knot in the Milky Way. It looks like a bright section of Milky Way. And if you look at it, it's a big object. Messier included it as his 24th object. So this is Messier 24. And what it is not actually a star cluster. It's an opening in the dust in the Milky Way through which we can see thousands of light years nearer to the center of the galaxy. So it's like someone's cleaned a window in the dust of the Milky Way, and we can peer through it to see the much richer interior of the Milky Way. So that thing is quite big, and you can see it with the naked eye if you're looking from somewhere dark. As you go south, you're heading towards the center of the galaxy, but you're also heading into kind of thicker layers of the atmosphere as well. So we never get a good view of the central part of the Milky Way. I'm nearly done, okay? I just want to point out one or two more kind of like things that people will probably look for. Over in the eastern sky, Mars is coming up there, but this is also kind of the beginning of the season where you can start looking for galaxies as well. Looking into this direction, you're looking out of the Milky Way into intergalactic space, and our nearest galactic neighbor is the Andromeda Galaxy. So that's all at the moment, and it would be, I guess, it would be a nice wide field picture if you can get the Andromeda Galaxy and another near neighbor, the Triangulum Galaxy, which is down there. If I zoom in, you'll be able to see it. So there are a few bright galaxies in this part of the sky that are well worth looking at as well. So that's M33 Triangulum Galaxy. These galaxies are roughly 2.5, 2.7 million light years away from us. And famously, the Andromeda Galaxy is on a near collision course with our Milky Way. Right, okay, I think I'm probably going to stop talking there. oh, one more. I'm not going to talk all night. The constellation Cassiopeia, if you've got binoculars, easy to find because of its distinctive W shape. But again, this is just a gold mine for astrophotographers and visual observers. The W is just embedded in a rich part of the Milky Way. So there are things like the Pac-Man Nebula, which is right about here. There's the Pac-Man Nebula, just a shell of hot hydrogen gas. You zoom out again, down here, we've got the ET cluster, which I imagine is somewhere around about there. Phi Cassiopeia. Looks less like ET on the screen than it does through a telescope eyepiece, but it's upside down. Two bright eyes, a body, arms outstretched. Yeah, can you see that? Make it obvious. Could be the, yeah, it's an alien. It is. Yeah. So I think I'm going to stop there.